Okay, so 4th October 1957, launch of world's first ever satellite, Sputnik 1. And with that, Indian scientists started dreaming about indigenous Indian satellite program. After the success of Indian-built Rohini rocket program in 1960, the Indian Space Research Organization shifted its focus to building indigenous satellites. And eventually, 19th April 1975, the rocket thrusters fired to launch India's first indigenous satellite, Aryabhat. The Aryabhat launch was successful at a time when leading space power had little faith in India's chances to produce an indigenous satellite. So, how much distance the Indian space program traveled in last 85 years? A very good afternoon to each and everyone present here, and I welcome you all to the Inaugural session on Indian satellite and its application, organized by Bharati Vigyan Jilla Vishwakarma Mahavidyalaya and IEEE BVM Student Branch in association with Vigyan Gurjari. Now, I request Dr. Indrajit Patel, sir, Principal BVM Engineering College, for the inaugural speech.
Namaskar, and to all of
Yes.
you present on this digital platform. Distinguished speaker of today's webinar, Dr. Steve Mohan, former director ISRO, Vigyan Gurjari, National Executive Member, Dr. Vigyan, Ram Sachiv, Dr. Vigyan, Dr. J.M. Rathod, Faculty Advisor, IEEE Student Chapter, Dr. Darshan Dalwadi, Counselor of IEEE Student Chapter BVM, Sneh Trivedi, Nisarg, the office bearers of IEEE Student Branch BVM, all my colleague faculties and beloved students. I wish you all a Merry Christmas, blessed Gita Jayanti, and greatly remember my beloved Prime Minister, late Sri Atal Vajpayee, on his birth anniversary today, 25th December. This very great day that three different stories. One is the second is IEEE BVM, and third, Vigyan organizing a very flagship event. Just we have ended the Indian Science Festival. Our visionary and dynamic and beloved Prime Minister Sri Modi, and concluded by our Honorable Vice President Sri Venkaiah Naidu, witnessed with varieties of the activity during these 2.5 days of very important festival in the area of science, technology, and innovation. I welcome you all on behalf of Board of Governors Jilla Vishwakarma Mahavidyalaya, IEEE Student Branch, as well as Vigyan Gurjari, whole of Vijayanagar and Gujarat branch, for this important seminar on Indian satellites and its application. Jilla Vishwakarma Mahavidyalaya, the premier institution of Bharati Vidyamandal, working since June 1948 with a motto work in workship, and presently Team BVM work with a vision to produce globally employable, innovative engineers with the core values. The leaders at Jilla Vishwakarma Mahavidyalaya, and mentors at PVM, and all the stakeholders always strive hard, work with the head, heart, and hands together for the all-round development of the students who join BVM for the 4 years undergraduate program. We always believe to inculcate the variety of the skill, not limiting ourselves only to the curricular activities, only addressing the curriculum between 2 pages of the textbook, or not only confining the students in the four of the laboratory classroom of the library, but we would like to expose our students beyond curriculum, beyond classroom and beyond laboratories by way of hosting such type of the activities. The various professional chapters, IEEE, CSI, IATE, IEI, Robotic Society, NSS, NCC, and Bachpan NGO at Birla Vishwakarma Mahavidyalaya try to address each and every attributes which are a part of our vision statement. The team BBM, even during pandemic time, from 21st of March, we started offering lockdown. Has not shut down their doors and windows in terms of organizing the variety of the activity along with online learning. I'm happy to share that more than 1,050 plus activity has been placed by our faculty. We have organized more than 120 plus activities and 32,000 plus people have witnessed the variety of the program, workshop, webinars, activities from more than 32 countries during this pandemic time of 8+ months. So we believe to deliver what we have, we believe to share what we have learned. We believe to invite the people who have contributed their life for the betterment of the society, for building the nation, and to make the development of entire global community to be sustainable model. We always try to correlate our vision, our activity, our experience with the national vision. Since last 4.5 years, under the able and dynamic leadership of our Honorable Prime Minister Sri Narendra Modi, always try to imbibe the core values, the, the phrases like Digital India, Stand Up India, Startup India, Innovative India, New India, work with a zero error, zero tolerance, and now the present phrase that is Atmanirbhar India. Even during pandemic, we have organized two flagship events, the Atmanirbhar India Ideathon, as well as Atmanirbhar India Hackathon, in which 800 plus students in the Ideathon and 1200 plus students in the Hackathon from all across the country have participated and come out with very innovative ideas. I'm happy to say that recently the team Electronics of Birla Vishwakarma Mahavidyalaya have won the third prize in the Digital India category at IIFS 2020 Festival recently concluded. So we want to imbibe the technology. We want to address the core values. We want to imbibe the true spirit for the nation development. We believe that students should grow, families should be benefited, society should be uplifted. At the same time, the progressive and sustainable development of the nation should be at the heart of the student, at the heart of the faculty, and at the mind of the institutions, so that we can make our country a new India by 2022. I'm happy that IEEE Student Branch is constantly engaging varieties of the activities to nurture the youth for their growth, for the growth of their family, for the growth of the society, and development of the nation land. We have recently now collaborated with the Vigyan Guruji under the leadership and the mentorship of Dr. Vaidya, Dr. Prashant, and other office bearers at the national and state level. We are going to establish a student chapter at our campus, will be institutional membership, and we will have more and more programs in the days to come to merge science, technology, and innovation on one platform and making our India a country in line with USA, Japan, Korea, and other developed countries. with a concept of Atmanirbhar. We were Atmanirbhar during Dwapar Yug, Treta Yug, whether it is the satellite communication, whether it is the wireless communication, whether it is the defense technology, everywhere we were Atmanirbhar. But during the British Empire, we have lost the track. But again, since last 4.5 years, we are on the track of building a nation to the self-reliance and Atmanirbharta. I wish this program a grand success. Thank you, Dr. Siv Mohan, for again being with us on a digital platform. He was there for one of the flagship event on campus for 2 days at Vigyan Vishwakarma Mahavidyalaya, and he is a very visionary person so far as the satellite communication and other technology are concerned. And we are grateful that Vikram Sarabhai, again a Gujarati, who has put this milestone of this ISRO, and it is taken care further, again taken by Prime Minister Sri Narendra Bhai Modi and the Chandrayaan mission. Though we have not attained 100%, but in the next, round, I'm definitely sure that we will reach to the south pole of the moon, and India will create a history in the space technology. Since last 5 years, we have ISRO has given many important missions. Even we are now launching the satellite of the other countries, including Russia, Israel, and developed countries. So now, so far as the space science is concerned, we are Atmanirbhar. We were, but we are more and more far better. So once again, I thank you all for being with us on this digital platform. May God bless all of us for a better future. Thank you very much.
Thank you so much, sir, for your motivating words. Now, I'd like to invite Dr. Prasant Kunjadia, sir, Sachiv Vigyan Gurjari Prant, to say a few golden words on the session.
Sir,
Prasant, sir.
आपनो mic on करिए please.
Okay, yeah. So, namaste. Thank you all, and I would like to thank organizer Bingla Vishwakarma Mahavidyalaya and under the aegis of Charudhar Vidya Mandal for organizing this program on the applications of space applications and satellite and other thing. And here I would like to talk about a little bit about Vigyan Gurjari or Vigyan Bharati, which is working since last 25 years in the country. Thank you, Siv Mohanji, for being a part of team, and I would like to listen your talk because I'm also highly interested in space application because nowadays India is one of the leading country and doing well, and now whatever we have invested, now the chance has come to earn on that and to pump more funding in the R&D field of research and applications. So I would like to talk about Vigyan Bharati. Vigyan Bharati has a K.I. Vasu in the Indian Institute of Science, Bangalore, and independently in 1982 around. Then 10 years of work has gathered similar kind of people throughout the India. In 1991-92, on 21st October, Vigyan Bharati has been established. More than 150 scientists have gathered in Nagpur on the first meeting. Since then, the work has started. The Vigyan Bharati has the motto is Swadeshi Science Andolan or Swadeshi Science Movement. You can say so. There are two things. The Swadeshi means our own indigenous, and science is everywhere we know, and movement. So basically, we wanted to see Indian science like astronomy, then metallurgy, then other kind of arts, Ayurveda, everything to put on the world's map. No doubt, under the able leadership of Narendra Bhai Modi, we have seen that yoga has becoming the international practice, and everybody is following or observing yoga day, and everybody is doing yoga for the better health of the individual. And all countries are taking part, even UN and other people have announced the Yoga Day. So similarly, our focus is on all these aspects, that we wanted to see that our people understands our science, take it to the at world level and put on the world map, so everybody follows. And the good part of the science, we all know that have in the day to day life, we are using a lot of our indigenous knowledge, not using everything from the outside. And our culture is very old, and we have very good scientists in past, and presently also number of scientists are performing at the world level. So we wanted to have this all people to work for the India, for the Indian betterment. Everybody is working also, but when we unite with some one particular thought or one vichar, we can say, at that time our energy is converted into synergy, and when there is a huge synergy, we can achieve goal within a deadline, and we can also have more and more kind of knowledge to be spread. So that with that goal, Vigyan Bharati has been established. Now in all the states we have our unit, and we are also having a units at different university level, Jilla level. Likewise, number of people have been joined. More than you can say 25,000 scientists have joined throughout this as a member of Vigyan Bharati, and number of people have joined in the different kinds of event. We are right now seeing one event that is called India International Science Festival, Bharatiya Antarashtriya Vigyan Mahotsav 2020. This is sixth series of event. Earlier we have already organized 5, and we wanted to showcase our own science and call people with a different with a different background of science and technology and other kind of innovative things on that particular day, within 3-4 days of that event. So we have started IISF with some small 8 theme. Now it had ended up with 41 different themes in 9 different verticals. So Dr. Vidyaji Vaidya is right now there. He is Akhil Bharati Karyakani member, and he is also a coordinator of one vertical, and also coordinator of Agri-Tech. So people are coming with more and more about science, and this time in the pandemic situation, we have organized whole event on virtual platform. So this is the what that हम जो प्रधानमंत्री जी बताते हैं कि आफत को अवसर में कन्वर्ट करना है. So that is what we have done, and we have proved that we can we can think together, we can do things together, though we have some problems like pandemic, or we cannot meet physically, and everybody has put their own thoughts and works on presented their works on virtual platform, and lakhs of people have seen. Similar different kind of activity we are Vigyan Bharati is conducting. Like for school students, we are conducting Vidyarthi Vigyan Manthan. That is one of the flagship programs. Almost 1 to 1.5 lakh students are sitting every time in this event. And the national camp we organize always in one of the national laboratories. So where students have to come, see, talk with the scientists, do whatever they want in the laboratories. It is kind of open laboratories for them. So we inspire students to take field of science, because we know that nowadays there is a little bit hesitation to take science due to a lot of competition and other things, but there are a lot of opportunity also at the same time. So students should have that knowledge, and those who are intelligent, we want them to be part of the nation building team in future. So either directly or indirectly they can contribute to the country. Similarly, we are having a number of activities, 18 different activities we have, where we try to address not only advanced level science, but we also work on the social science also. Those organizations which are working as NGOs, we also want to provide a platform where they can have some latest knowledge, and they can take that knowledge to the the society, because we know that in India a number of schemes and projects, government projects, and whether it is educational, health, and other kind, they are the people who is taking to the people. So it is the duty of scientists or as a science organization to bridge them with the current innovations and those who are facilitators. Similarly, we have also worked a platform like IFA, where we are trying to address problems of industries with the academics, because we have seen that in India, industry and academic collaborations is very less, and both are working independently. While there are resources at the academics and expertise also, and at industry we know that an MSME where the investments and other things are there, they cannot do R&D and other things. So their problem has to be solved by the academics. Like we have a Birla Vishwakarma Vidyalaya in Vidyanagar, and next door we have a GID Vitthal Udyog Nagar where 300 industries are there. So there should be bridge between them. So obviously we as a Vigyan Bharati, we are trying to work on it, and in many states this kind of activities have been established. So these kind of things Vigyan Bharati is working. Vigyan Bharati is also working on one platform called GIST, that is a global Indian scientists and technocrats. We wanted to have knowledge and experience of those who are doing well in abroad with the local level. So they can also talk to the people, they can also join with the people, they can do some joint projects. So these kind of activities we wanted to promote. So Vigyan Bharati is not only working on the what you can say the science of our own. They also work with the current science, means current trends of the science. We know that all the major institutes are having a role in right now in the IISF. We have a CSR, we have DRDO, we have DBT, DST, okay, Ministry of Environment and Science, MOES. Everybody is scientists are playing some or other role in promoting science through the masses. Because ultimately, if whatever technology we make, if there is no buyer, it has no meaning, and it has to be user friendly. So more and more deliberations are required on this aspect, and these people we have to. So it is our duty as a Vigyan Bharati to provide platforms to those people, those who wanted to interact with this. We don't say that other people are don't work on it. Other people are doing also doing nice, but as a Vigyan Bharati and more number of people, we can do it better. That is what is our all organizer Dr. Darshan ji. He has done tremendous efforts in organizing this. Dr. Indrajit Patel sir, Dr. Shiv Mohan ji, also I am thankful to you. So thank you all.
Thank you so much, sir. Now, without wasting more time, I'd like to welcome our eminent speaker for today's session, Dr. C. Mohan sir, ex-project director, Reset ISRO. C. Mohan sir has served as a chief scientist, Haryana Space Application Center during 1998 to 2001. He worked as a project director, Reset Utilization Program of ISRO during 2009 to 2011. He was the recipient of the ISRS National Sensing Award in 1995 for his efforts in the area of microwave remote sensing application. It's our privilege to have your significant presence here, sir. So, I'd like to invite Dr. C. Mohan, sir, to take over the session.
Thank you, Shri Bhikkubhai Patel ji, Chairman Charuttar Mandal, Dr. Indrajit Patel, who is Principal of BBM College, Dr. Prashant Kanjoria, and Dr. Rathore, Dr. Dalwadi, and other colleagues, and IEEE BBM team who are organizing this, and all other organizers and participants of this webinar. I am happy to be part of this, as I see that one of the most active support from the management and from the organizer for various activities which the Vigyan Gurjari Prant is doing for people of the state. So it's my pleasure, and I will just share my screen now. Pardon? Hello? Share your entire screen, it's shared. Is it seen by you?
No, sir, it's not visible. So there
Okay,
is one
again.
option on present now in that
Present now, okay.
entire screen, right?
Entire screen.
Yes, yes. Now it's visible. Yes, it's visible. Right.
Okay, now you are seeing.
Yes,
Okay.
yes, it's seen, sir. Yes, yes, it's clear. Clear, sir. Yes.
Now it's okay. Hello.
Yes,
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 sir.
sir.
All right, all right. You are able to. So, I will just talk about Indian satellites and how we are using for various application in the country, and how a small example or few examples how we can use it further for some of the applications in India. So for those who intend to start from beginning what is satellite means. When we were doing astronomy, that time satellite means a natural body or celestial body. Celestial means one you see in the sky that orbits around Earth or any other planets. Like Moon is a satellite of the Earth. Now, subsequently, people thought of sending artificial satellite. Artificial is a artificial body which is made of any material which can handle various rays in the above the sky, and which revolves around the earth or any other planets. Not only revolves, its purpose should be to collect some information about that planet. Only then it is a useful device. So 1957 was the first artificial satellites by Soviet Union, which is called Sputnik. And 18 years later, India also started Aryabhat on 19 April 1975. And since then, we have about 120 satellites uh, in the in our overall numbers of the satellite which India has launched. The way satellites are important, that's why all the nations in the world now going towards that. One important thing is that we can see the larger area from a height, like from any height of any tower. We can view the larger part of the city or larger part of any area. So we want to see more area in a given time. Advantage is that you can talk about anything on that area, about the objects, about what is happening in those areas. So satellites are basically used for such kind of applications. And if we go above the atmosphere, then we can view the other satellites, other objects in the space. You can put your telescope, you can see the total universe. You will see that the different kind of images which a Hubble telescope is collecting of this universe, and people are trying to find out how, where is the end, what are the voices, and all those things. Third important thing is to the mankind is direct application is the satellite communication. We can communicate with each other for long distance. Earth is not a flat surface. You can see because of this curvature, and wave travel always in the straight line. So wave cannot travel from here to here because of this curvature. Short communication, yes, but long we cannot. So you need some media which will collect your information, transfer to other locations. So satellite communication is one of the potential use of these satellites, and it has changed the world what we have today. And fourth is important thing is we can know the location of any object on Earth space, which was difficult a couple of years. Oh, technology was available, but not available to common users. So these kind of satellites have changed the day-to-day life of the people in this world. So when a satellite is built, it has a different purpose altogether. One has to define what for we are launching the satellite, what we want to do, and accordingly its orbit is defined. Orbit is a path in which a satellite will travel all along throughout its life. So these are three types of orbit. One is low Earth orbit, means like 300 to 400 kilometers above the Earth's surface. One is polar. Polar means from pole to pole, it moves, descending from here to here, then again ascending, and movement of Earth's surface in from this direction, and it covers a total, what you can say, the globe when it completes one total duration. Geostationary means it will see the one part of the Earth at a given time and constantly over 24 hours, like you put 24/7, because other satellite will pass over this and they have to come back again seeing the same place. But geostationary means it is stationary at a given time or all the time. So 24 by 7, it will see same location on the Earth surface. So geostationary is important for some of the applications like communication because it is at a fixed location. This is roughly something around 35,800 kilometers from Earth's surface. And as soon as Earth moves in this direction, satellite will also move. That means it is locked with the satellite. Its speed is locked with the Earth's movement speed. So it will always look a fixed point on the Earth's surface or fixed area, not a point. So once it sees a fixed area, the two purpose it serves. One is when I want to communicate from this point to other point, satellite should be stationary at that because I am transmitting to this. It should not happen that a satellite changes its location. It should remain fixed with reference to transmitter and receiver. So that's why geostationary satellites are required for this. Other is if I have to monitor the cloud and its movement, I have to be fixed location, let cloud move. So I know the how clouds are moving at what height and what is the temperature. All those things are required for various meteorological applications. So this kind of satellites are used for communication as well as for the weather predictions and the monitoring of that. Other is called polar satellite. As name suggests, it moves from pole to pole, and Earth is rotating from this to this direction. And once it comes again, it takes 100 minutes to complete one's orbit. When it comes again, by that time, Earth is shifted by some degrees. And then it takes image or photograph of that area and this covers the total globe by, it's called a temporal resolution. And then after how many days, satellite will come to that location. So one can design the satellite according to you want every day, you want once in 10 days, or you want once in 6 months. So depending on the application requirement, this is decided the what is the temporal resolution. All our Indian satellites are varying from a week to 15 days or 20 days or 30 days kind of resolution, temporal resolutions. So as I said, the Earth keeps on moving and satellite is in a fixed plane. So when it moves to next location, it takes the image of that area. So that's how the total, you can say it covers total globe. Now the area which it sees at a given time, now you can see the satellites sitting here and it looks the total area at a given time, that is the called the swath of the instrument. Like I can see at a given time 100 kilometer or 10 kilometer, that is called swath. And what is how much minimum I can resolve. Suppose I am seeing the 100 kilometer and I want to resolve each 10 meter. So my resolution is called 10 meter and swath is 100 kilometer or depending on what I have decided. So these are decided based on the what application one would like to do with the satellite. So both are important. One needs to have a larger swath, means I want to see larger area at a given time, and high resolution means I want to see each and every inch on the earth surface. So both things are normally required by the users, but one has to limit because both things cannot be done at a given time. So one decide high resolution or higher swath. Normally, where we use the payloads of climate change or related, we do the low resolution and higher swath, something of that kind. If we are looking for the construction activity, I don't need daily, I need lower swath also. So, so seeing the importance of these satellites, all countries are now doing the job which somebody started in this world. So Operation payloads are maximum from US. You can see the 350 to 1630 as on July 18. And green shows 100 to 350, China, this and Asia, some part for Japan and so on. And India is nearly 50 to 100 in July 100. July 18, we have light green, and these are some European countries where we stand comparable with them in number of satellites. So total globe is now uh, one part is US, the maximum number of satellites. Other part is remaining part of the world. They all together compose a number which is nearly equivalent to US or slightly more than that. At a given time, how many satellites are active in the world? All over the globe, it is 1419 present satellites. As I said, the dominance of United States. So they have 576 satellites which are active. Otherwise, dead are more than 4,000. And Europe, India, Japan, those who are coming up, they have about 40% share, nearly equivalent to US. China on its own 30%, and Russia is about 10%, 140 satellites. So these are the distribution of the satellites, and number doesn't represent you are better, but number certainly represents your applications are enhanced in those part of the world, and you are serving your society using satellite as much as possible by that country. Now, overall, if you look at what kind of satellite, as I said, communication satellite, remote sensing, or Earth observations. So nearly, if you see the Earth science or Earth observations cover something around 26% of the satellite. More is in terms of, you can say, the communication and navigation satellites cover nearly 50% of this. So more application, because now communication is the prime kind of use of satellites by the human being. So they cover 50% of satellites are for communication purpose, and 10% are for navigational, because navigational purpose, those satellites are having a very long life at a given time. So suppose you launch it and it may have 10 to 15 years of life. So they remain there in the orbit, and number is also fixed because you don't want to increase too many maximum satellite. For example, India will have 7 navigational satellites. US is having about 34 navigation satellite, and they will remain fixed for next 10 years because we are not extending the limit of it serves the purpose of what navigation we want. Now I want to know how it is my satellite is working, live real time tracking. And this I am putting from the point of view of you student community and those who are interested to know. I have just from this website, I have just found how many satellites are live in from my countries. So list, it gives a list, December 20 and what has been launched, and I will say track it. So it will track. I am not an expert of satellite. I am not an expert of tracking, but I will know where it is. I am tracking now one satellite, for example, RISAT-2, which was launched by India recently. So this just day before yesterday, I tracked it, and its location was found here. This is RISAT-2. So one can track any of the slide. What is the use of this kind of public, a kind of website? It helps you to know where is your satellite, what you can do with this satellite, and not only that, from where I am tracking this satellite. This website will put me, I have put this red color. That means I am the person who is tracking this satellite. So I have tracked RISAT Indian satellite just after a few days of its launch. Stationary, geostationary. Whenever I track it, I am again from Ahmedabad, I am launching, seeing. It will tell me that this satellite location And even if I track it tomorrow, it will remain fixed. It will not change because, as I said, these satellites are fixed with reference to your location. They cannot move because if they shift the location, you lose the contact with them and you lose the communication to other persons. So it's a fixed kind of location all the time. So one can always and set this you can always see who else is using this kind of information. So number of green color, if there are more, that means more number of people are using. So India, you can see so many people do use this website as an enthusiastic person, as a just to know where it is, but not much in African or even Europe. There is large density US. So it also brings out the people's ability to connect through internet to the world, and that ability is better in US, Europe, India, Africa. It doesn't get. China, it is less because China is not too open, but certainly they connect to the internal network, which doesn't come into this website. So now we will talk of type of satellites. As I talked, different purpose, different satellite. One satellite doesn't do all the job. So communication satellite, of course, it is a, and as name suggests, communication is important or prime thing in today's world. It communicates with the people all over the world. Earth observation means you're trying to get information about the Earth at various in various ways. And technology used here is the remote sensing. So they are also called the remote sensing satellites. Third is navigational satellite, means it is purpose is different than communication as Earth observation. Purpose is to find the location of a person or location of a receiver at a given point on the Earth's surface. Weather satellites are mostly used for meteorological applications in India, and effectively after the launch of this kind of satellite, meteorological predictions have gone much better than earlier days. Even the losses because of typhoon and other things, other disasters have become less. Then recently, India has changed, Indian ISRO especially, changed its mission directions. Earlier it was only Earth, but now they have changed since last about a decade to planetary missions. That means you try to understand other part of the globe like Moon, Mars, Mangal, or then you have the Venus and so on, and also human space flight. So in order to read all the benefits what one can get from this part of the space, which is not fully utilized. So why we use communication satellite is important. As I said, electromagnetic wave, they travel in a straight line. So I cannot communicate with a person sitting on the other part of the globe unless I have a wire media. So we use satellite. We communicate first with the satellite, which is called uplink, and with downlink, that means that signal we downlink here down and to other station, which is called the Earth station. So these are two Earth stations which are communicating with this satellite, and from here we distribute again to local stations or wherever we want to communicate. So you need a Earth station, you need a satellite, and you need a other two Earth station for communicating with using the satellite for this purpose, communication purpose, and then it goes to local network. It may be anywhere, White Tower or any other. Other thing is if there's a mountain or other very high mountains, then also we cannot communicate. We need satellite. For example, it's a hill. I cannot directly transfer my signal because a straight line, it doesn't pass through this. So I am not able to communicate with the people on this side of the hill. So I need again a satellite for communicating with the people from this part to this part. So that's how satellites are important, communicate with each and every part of the world, and especially even now it's a different part, all parts of the world are connected through satellite systems of one country or other. As I said, it's the number of satellites. Each country has its own satellite sitting over their own locations, and this is sitting at roughly 36,000 kilometer above the Earth, and each satellite will have their own. Like India will be on its own place. Globe is doing at other places. So all countries are trying to have their own satellite who don't have capability, but they buy it and get it launched from anywhere in the world. India is cheapest today for launching purpose. And these, in addition to communication, like telephone and other society-related work are being done, which is government supported program like telemedicine. Hospitals are connected, like the specialty hospital where specialized doctors are available, and village and district or small town, they don't have that facilities, so they can consult a doctor through satellite communication, and they can get advice or whatsoever thing. And suppose in village there is no possibility of any tower, one can have a vehicle which goes there and get connected to satellite and get all the information from the specialty hospital. So these kind of are the government projects and are available for use of the public. Other important thing is the, as you said, network. It's also now various universities have started this kind of network, and which was initially started by Space Application Center Ahmedabad, the, as you said, program, and where we demonstrated how we can use satellite technology for the educational purpose. So subsequently, it is now a well-established kind of network. People are getting connected, and various education institutes are also getting connected to this kind of network. And third important is the disaster management. Suppose some places disaster happen and there is no telephone connectivity or satellite connectivity, then this vehicle it will go to those locations and start communicating, because once any disaster happens, first task is to get connection and to get the latest update about those, so that before any help is provided, one knows the status of the kind of disaster, level of disaster, and so on. So it saves a lot of time and immediate relief is possible. So as I said, applications, telephony, television communication, radio communication, mobile satellite technology, and we have internet, of course, high speed now useful, and military, which remains unnoticed many times because how military is using. So that's also one of the important applications, which doesn't come into picture to the public that how it is going. Just I put one example, and it detects one of our satellite is GSLV. I just put, because we cannot put everything for the military whatsoever available in the media. Same thing can be repeated, like detects aircraft, vessels, at real-time air-to-air communications means various aircraft you can communicate now. Drone you can communicate with the drones to take video on, or you can instruct the drone itself and any place. And our northeast region is fully supported this kind of services, and of course improving the long-range communication with the distances, long distances. Now I come to other categories, which is navigation satellite. It started with the US, who started a GPS, consists of GPS satellite, global positioning satellite. They had 32 satellites in 6 plane, and purpose is to know location of any object in the world. Now, when this kind of system was available, they have made it available to the people only, just it was available to total globe, but nobody was allowed to use because the information was not transferred to the local people or local government by them. They were keeping it. So subsequently, other countries they started working on their own GPS, like US, USSR, the Glasnost. China has its own. Japan had its own local network, and yeah, India also started its own network, which is called Navik. So for the knowing location, you need in your area, you don't need so many satellites like US, about 24 to 36 satellites because they want to cover total world. But India, we don't want to cover total world. We want to cover our own country. That means our own region. Little more than that, Andaman Nicobar, obviously Southeast Asia region. And we need in that about minimum satellite requirement is 4 in order to know location of your receiver. And this works on the principle the time at which signal is transmitted by the satellite and it reaches to your receiver. The time is noted, and this time uh, is noted for all 4 satellites, and it is solved to find your location. These timings are again solved with equations which are solved to resolve your exact location. For example, if my if I'm standing here, my 4 satellites, suppose one satellite has transmitted the signal. So once it comes back, this is called range R1, R2, R3, and R4. So I get 4 this kind of sphere, and wherever they cross each other, that's my precise location. So this is the very basic principle of finding. So what is important here? The timing measurement should be very accurate because even few seconds will make you kilometer away. So that's a atomic clock is used when in these kind of satellites, and that time is measurement with reference to one of the satellite and others becomes relative. So you are able to get very accurately time measurements and accordingly distance measurement and your 3 dimension or 4 dimension accuracy. So we use this kind of satellites for automobile, aircraft location, boat, ship equipment, cyclists, hiker, everybody nowadays, common people through our mobile we use, and we are using GPS, not our Indian Navig is still to be built. Indian system will be working only for this yellow region, like any local. Japanese have their own local, Chinese have their own local, and Russia and US will have a global system. So we our advantage, our own system, you could be more accurate, and because other countries at the time of crisis means war, they reduce the accuracy of their own satellite, so you miss the target, so you lose the overall system, defense system. So that's why it's very important for your own country to you have your own Navig satellites. Now I'll talk of weather satellite, what we do with these satellites and what are these satellites. They are stationary with reference to Earth. They take the images of Earth's surface. And if I am worried about local weather, I am looking one part of my Earth. That means India. I am looking my one satellite is enough. So I can look because it's locked to Earth. I can look this part 24 hours anytime. I can look it. If I am worried about the global world, minimum 3 satellites are required for covering the total globe, which is US is doing. Our interest is more of Indian region, so we have 3 satellites at the time available, and mostly we are using 3D for various applications, which consist of uh, 2 camera, one in visible region, one is near infrared region, which provides images of the Earth. Earth means all clouds, and also it provides information the water vapor, NO2, CO2, and other variant atmosphere constituent of that. So if you see that I'm talking about 3D, like we have two, and Kalpana, one of the first satellite is Kalpana. And you can see it has a very long life, these satellites, because nothing goes wrong in these 13. So it's 7 years, and still it will continue next 3 4 years. So it is one of the advanced weather satellite which has helped country in many ways in terms of weather vagaries are less, and it has, as I said, a resolution of 1 kilometer, means every kilometer on our Indian continent I can see using this satellite, and it has five other bands in the infrared, and which are used for water vapor or other constituent of the atmosphere, and thermal band when in the night, what is the cloud condition, because night you cannot see using visible, you need thermal waves, and it has a sounder which gives the atmospheric constituent of the surface over the India, which are responsible for various meteorological prediction. So if you want to know more, and if you want to practice with this satellite, you can directly go to some of the sites. It does a lot of work like forecasting of Indian weather, sea state, rip currents, lightning condition, heavy rains, heat waves. All these are done by these weather service, cold waves and city weathers. All this satellite is doing so. Nowcast, you can do it with this satellite. And also, if you want to do live, you want to see live how it is happening, how satellite is collecting the data, you can directly go to this link, our Indian MOSDEC live. It will show the live condition, what the satellite is doing. It will show you images of Earth, how cloud is moving. You can also add vector layer to that, means you can add name of city what you want to see. It's a very user friendly, and this is made for the various purpose. One is the organization like you, where you want to create interest among the community, that they can directly see these kind of satellites and how it is collecting the data, what will be the forecast of my area, what is the forecast of heavy rains, and everything is shown on this satellite that is called MOSDEC Live of ISRO. I've just put the map which is created from this MOSDEC Live, a map which are the showing the risk areas, like the risk areas because of cyclone. For last couple of years, where cyclone was more affected, more reddish is shown here, less affected discolor and minimum effect. So this helps us not only to know various effect, but also to know where I should buy my property and other things. People start using them for various purposes. Of course, now risk factors are getting reduced because of various reasons like the government support and advanced information, because we can forecast many of such risk which is likely to happen in these. And we can also look for various risk map like fire risk, landslide risk, or landslide forecast from this kind of satellite system. There is one more is called a rapid, which is gateway to Indian weather satellite data. This gives you all information on the cloud motion vector, cloud temperature, water vapor, and so many things which could be used directly for research purpose instead of driving all these information. And one can use for various research analysis as well as your day-to-day functioning of you yourself want to know the weather condition. And it also provides, this rapid also provides a real-time analysis of some of the data. You may be curious to know what is the forecast for my city. Now rapid gives you also information, crop type also. I have put a crop information of in this area, how green means more healthy crop. These satellites have, as I said, 1 kilometer resolution. So a broad information graph crop also I can get from meteorological satellites. Though it is purpose is different, but one can see that its abilities are beyond what for the satellite is made. For example, is a cyclone Niva, how it is moving. It was forecasted on our Indian ISRO portal, how it will be moving. And these are the areas which will be influenced because of high winds. These are this darker tone is where the effect will be more lighter tone. So any administration, it goes to administration also of concerned cities as well as general public to know up to what extent this cyclone will be affecting us. So India Meteorological Department is one of the maximum user of this kind of data, satellite data. You can go to their website and find out various parameters like how is the information of clouds and so. I know once there was people wanted to know at time how much is the cloudy conditions for various observations on the sky. So it becomes useful to public at that time, especially I know in Gujarat there was an eclipse. Somebody asked me, can you tell me where the clouds are minimum? So I just looked this site and within a half an hour, I conveyed these are the things. The clouds are less, these are the location, the clouds are more. So he could find. So these are the simple applications which people can use them for their day-to-day purposes. Now I come to observation satellite, where the Earth observation satellite, where purpose is to know each and every part of Earth, means its health, its people, and everything we want to know what is happening on the Earth surface. They uses the remote sensing technology for the uh, analysis of the data set. Remote sensing here means taking images of the Earth surface, what I put here. Sunlight, when it reflects from various objects on the ground, it gives you different intensity. And this signal is being put as per the location of that object, whichever it reflects. For example, trees from here, it will put tree here and like this. So it creates an image of Earth surface, which is the actual condition of the Earth at that particular time when data is acquired. So remote sensing we do with the light wave which are seen by us. Sunlight, which consists of 7 colors, and we use all those 7 colors. But we remote sensing has advantage that you can see beyond what a human eye can see. That means infrared, which I don't see, thermal infrared, which I don't see. I can also do similar reflected rays and I can create images of the Earth surface, which has advantage of additional information like evening. This sunlight, when there's less sunlight, I can see the tree still because infrared waves are there, which are reflected by this plant, and these waves have advantage of having more information which is not visible to our eyes. That means in terms of water content in the leaf, in terms of chlorophyll content and other content on this plant surface. So we use all these wavelengths, and that is how mapping the invisible. What a human eyes cannot see inside the tree, remote sensing allows you to see all those substances present in this tree. That means its water content or its chlorophyll content and other parts which are responsible for the growth of tree. So you can map all those components of the tree, and in addition you can map the various covers on the ground like soil, how it behaves at different wavelength, water bodies, vegetation, and so on. And each has a unique spectrum. So we collect the spectrum of the Earth surface. At the spectrum here, I mean the reflectance of the object at different wavelength. We measure them, and this helps me to, instead of image, now remote sensing community, they don't use image. They use the spectrum to identify the object and its constituent present in that object. So different way of doing the remote sensing. One is passive, means when sun is illuminating the earth's surface, you get the reflected light used for various analysis. When in the night, what you do, you illuminate the earth with your own signal like lidar, radar, and what it comes back to you is being analyzed. Why we need at time? Because when there's a disaster, you don't have sunlight, you can't take photograph, so you need your own source of illumination. So for serving that kind of application, we need a active kind of remote sensing system, which is normally radar. In addition to this, requirement is all the time that I want to see each centimeter on the road or each kilometer on my area or larger area at a time, because when I see the cloud, I don't want centimeter, I want kilometer. So clouds are not of small size, a kilometer to 10 kilometer. So country needs all kind of resolution at a given time. So country has also made, also served all these kind of user community to provide over these years 1 meter to 1 kilometer data set. Not only this resolution, but also information content. For example, in daytime, we take photographs using visible light. Infrared, we use for information related to what is present inside the plant. Thermal, we use for the knowing temperatures of those plants or many studies related to temperature. And micro we use when there's no, when the cloud is there and we are not able to penetrate to, we use micro signal, we penetrate, and the what reflection come back, that is analyzed in terms of various ground covers. So as I said, we can talk of a global scale, means kilometer to 10 kilometer data set. The total world, different color represents different categories, or a regional scale for the country I want to study. I am not concerned for the world. I can select that kind of resolution, or a meter scale when I'm talking about a study of my own where I'm living, or my own town, or any activity related to my town. So India has done great is using activity for various applications related to agriculture, soil, renewable energy. You can find the various source of energy, forest, how much forest and how environmental degradation, geology, governance, land, ocean, and atmosphere science, rural development, urban development, water resources, and all fields are being explored by India. And now, with the present Prime Minister, we are trying to put all the technology to the various ministries of government of India. As an example, the activity done for the crop, like the you can see the how crop is growing in the area. Red color is indicating that how crop is growing in one area, and you can see more the area, more healthy is the crop and more area covered. And this can be done at different scale, means say very high scale to regional scale and at a country scale. So all this activity is being done by Department of Agriculture. They do it for various activity like crop production also. One can also is use this kind of how yield loss. For example, this study is related to crop damage due to locust in the Vav area of Gujarat last year, 2019, and the green area, which is a vegetated area, is being lost. 17 December, the green vegetation, and 22 December, you don't have that vegetation. 3 days or 5 days is total area is we have lost. So one can work also on the damages or yield loss due to various calamities or disaster, which is helpful also for insurance activity. So country is doing, government is doing now crop production forecasting for major states, major crops like jute, sugarcane, cotton. Rabi, and our planning is planning commission using all this data for the purpose of planning. In addition, the development is taking place of the additional crops are being added to these numbers, and government is fully using such kind of technology for their day-to-day work. One can also see the global technologies available wherever world there is no local satellites, they can use this global satellite data like global cropland monitoring. This shows the how much area is being harvested on what date. So there are four different dates. So keep on giving this kind of, and that comes from the Google Earth Engine application. So these are the efforts of the global community. Suppose you have limitation of satellite data, but your brain to use this kind of technology is available. Of course, you as the prime agencies who are giving this kind of information to the globe. India is using for high resolution data like for various disaster, what it has happened, how much damage has taken place using our high resolution data. That is Nepal earthquake, how damages. You can see what you have to see the how intensity of the signal has changed. Wherever it has changed, you find those are damaged. This Kathmandu temple and this area nearby that. So you can see the Darbar Square. So these satellites help us not only to know area where damage has taken place, because earlier it was very difficult how much damage, what kind of service, what kind of help has been provided. With the help of such satellites, these things are becoming more, and government is fully using this kind of. In addition to this high resolution data set, as I said, we extend our vision to thermal bands. Like we want to know temperatures of the Earth's surface, like any forest fire, when there's a fire. Correspondingly, there's an increase in temperature which is reflected in satellite data. So government of India is using for finding the location of forest fire using this system. And there's a portal from government of India. They have shown how the forest fire in Uttarakhand has proceeded from March to April 28th. I think 2 years before. These red dots indicate areas where fire has grown up and how many tenders are required to control this fire. Now, other requirement for the country is related to see through the clouds, because optical sensor doesn't allow wave to penetrate it. You see only clouds. So our country is now equipped with this kind of satellite. It sees through these clouds and provide you images. Here the micro signal is illuminated on the Earth's surface, and what comes back are various intensities, different intensity, and these are analyzed in terms of information on the Earth's surface. And these satellites are used for various applications like the flood. For example, morning, it is a condition. Now this has been extended by evening time. So you know all the time how much area, and you can make a precautionary information to the people to vacate those locations. Also to know water layer, wherever, say during cyclone wave, it was very difficult to know how much area is got flooded due to this water. So this immediately shows, because this kind of signal penetrates to the cloud and gives what is happening. So these are additional black colors, additional water bodies which have been filled due to the cyclonic rain. Also to know how the water is added due to heavy rains. There's 2018 in in this area, how much water spread. So this is full Kate Brahma. Kate Brahma is full of water now. So one knows the how much water is available to your plant or your district or your state. Other is over exploitation of the earth. What you see on the surface just now, I am talking only surface feature, but what happens, the over exploitation does a lot of loss in the changes on the earth. The subsidence takes place on that, which are very slow, of the order of millimeter to meter waves. And you see that meter when you are able to, when some house is collapsed or something. So this technology allows us to measure or monitor those small millimeter kind of changes, and especially useful. Well, this is done in the Jharia coal mine, which are the areas where subsidence has taken place over a period of roughly 8 years. And this technology is now available to measure subsidence in various parts of the country. Now, there's a public utility available with ISRO's, which is called Bhuvan Portal. Many of you must have seen it. It provides you data free of cost. It provides you various services which could be utilized from Indian missions, Indian satellites. These services could be 2D information, then free data set, then climate related studies, thematic services, disaster management services, ocean service, and like that, including weather and other things. So all this information ready to use. Data is available for the scientific users, for the public, and those who have interest in this kind of research. And data is free of cost. Even other center of ISRO that is at Ahmedabad, they also do many of the applications for the public. Like you have renewable energy, you want to know. Suppose you have to establish your uh, some station where you want to convert your energy. You can find from this. There's a resource. It will tell you where the maximum energy would be available, heat energy or ocean energy, both. Then vegetation monitoring, you can monitor vegetation in your field itself. This kind of tools, air quality measurements are available. Urban sprawl, how much many cities are available. Of course, planetary science, and then related to water resource and other resource application. ISRO does allow training and research now. Those, of course, this year because of pandemic, they are not allowing. But this is open now to public student community, that if you want some training in any of this space field, you can apply here through this portal, this training and research. You will get support from that ISRO center. In addition, there is support from industry. What technology is available to the industry, that can also be, you can receive from this portal, and you can know that what are the things you can use for your industry. So uh, one has to know what satellite, and there's a portal which list all the satellites which are launched by, and recent one is US-1, that is communication satellite. Now, during pandemic, effect of pandemic, we have done this satellite launching, and earlier 19 we have 4 or 5 satellites, like 4 or 5 satellites here. Every year we are doing. Now there are certain more applications which are uh, beyond us to think of. I want to have a live track of my own area. That means, one, you people use Google Map. They are fixed for a couple of years. I want to know now recent one. There is a website called Zoom Earth, which very few people, student community should know Zoom Earth. Here it's very easy to develop my applications. For example, it is where I am staying. I have just, I can see each and every house here. Very simply, I just count my house number 1, 2, 3, 4, 5, 6, like this, my flats. And I can, if I am a civil engineer, I want to know how construction is taking place in my site. I need not to go. You can see this area is under construction. Construction has taken place. There is change of the. You can start seeing the building and other structures. And these they were high. I think 2 meter resolution also color image. Like here also, I can see construction has taken place in this site. So these kind of tools are available for public. Anybody can use. There's no cost, but one has to think of how. I have just given like civil engineers. They can use. They can find how much area is available for last 5 years freely. You can find out, and you can focus your search for those plots which are available and which could be contacted, instead of searching physically movement. So it gives you a lot of you can say the scope for developing your own business. So sometime ISRO, not now it is many times like when we launched Cartosat 2, it said Indian satellite can map 80%, 87% of area of Pakistan. You try to show the glory of the country that it can do much more than what we thought a couple of years before. And this 87% not for all, but very high resolution. I can find each half meter on that land what is happening. We were doing earlier, but not with that accuracy. Now it's much more accuracy. And keeping an eye on enemy is a glory to the nation. Strong eye on those. So it comes as a headline. But maybe we have that kind of thing available for the public and becomes a news. So ISRO achievements, it's a tally. You can see that we have 111 missions we had, 79 launches, and we have served 33 countries with 328 satellites covering various things like communication, GPS, Earth and weather. And of course, now we are going through planetary mission, which I have not covered, Chandrayaan 1, Chandrayaan 2, Mars 1. Now we are going to have Venus 1 in 2022-23 and also Mangalyaan 2. Chandrayaan 3 is also likely to be, but not sure when. So with this, I will say that ISRO achievement is not only our achievement, it's a glory of India because earlier India was known for IT industry, but now it is known for space industry and space application. Thank you for patience hearing. I will welcome questions from all of you. Thank you again.
Thank you so much, sir. It was really an intriguing session with full of knowledge and excellence. Now, I'd like to invite Dr. Darshan Dalwadi, sir, Branch Counselor, IEEE BVM Student Branch, for vote of thanks and words of appreciation.
Good afternoon to all the dignitaries, faculties, and all my dear participants. On behalf of the BVM Engineering College, I want to thank Engineer Bhikubai Patel, sir, Chairman, Charuta Vidya Mandal, and entire Charuta Vidya Mandal team for providing the support to organize this event. I want to thank today's expert, Dr. C. Mohan, sir, ex-project director, ISRO. We are honored by your presence, sir, in this program. I would also thank Dr. Ayan Patel, sir, Principal BVM Engineering College, and Upadhyaks Vigyan Gurjari Prant. I further want to thank the Dr. Prasant Kunjadia, Sachiv Vigyan Gujari Prant, Dr. C.G. Joshi, Adhyaks Vigyan Gujari Prant, Professor R.B. Subramanian, Adhyaks Vigyan Gujari, Vallabh Vidyanagar Unit, Dr. Amit Ballani, Secretary Vigyan Gujari, Vallabh Vidyanagar Unit, Dr. Vidyadhar Vaidya Sir, Executive Council Member of VIBA and Professor at Anand Agriculture University. I would thank all the participants. I would also thank Team IEEE BVM for organizing this event in online mode on two various platforms. One is Google Meet as well as IEEE YouTube channel. Thank you. Thank you very much to all.
Thank you, sir. Thank you all for joining with us with your valuable time. Have a great day and best wishes for New Year in advance.